Okay, so last time I taught you what polar coordinates and polar equations are. There's not going to be stuff on the AP exam just on polar. They're going to ask you to do derivatives and stuff like that with them. Okay, this is, I was going to say it's really close to, but it's actually identical to what we did with parametric stuff though. So it's going to be okay. It's just it involves trig. Do you remember how when we had x and y and we had dx dt and dy dt? It's that, except instead of t, it's going to be d theta. Do you understand what I'm saying? Like otherwise, it's the exact same thing. So when you go to do dy dx, it's going to be, oops, I miswrote that already. Dy d theta over dx d theta, which is comforting and kind of nice because it's not new information. It's actually what you've done before. The only difference is that it involves trig. Okay. Now, when you go to do a second derivative, same exact thing. You would do the derivative of what you just did. So derivative of this, and that's just a whole bunch of notation that means do the derivative of what you just did. And then what do you have to divide by again? Yeah, good, dx d theta. And last time it was dx dt, this time it's dx d theta. So again, it's not new information, and neither is this. Horizontal tangent line, what did you set equal to 0? Yeah, it was dy dt. This time it's going to be dy d theta equals 0, and then vertical tangent line will be dx d theta equals 0. I wrote all that out for you, and it looks scary because it's a whole bunch of notation and a whole bunch of thetas everywhere. But it's not actually new information, and that's really comforting, right? What you need to remember from last time is y equals r sine of theta. Right, let's write this off to the side. Y equals r sine of theta, x equals r cosine theta. And it comes from your SOHCAHTOA, which we kind of just reviewed right here. All right, so for number one, find the derivative of this. Well, first we're going to need to find y and x. So y is this times sine of theta. So it would be cosine of theta, sine of theta. X is this times cosine. So you could write cosine times cosine, or you could just write cosine squared. That's probably what I would put, means the same thing. And so here's our derivative dy dx. It's going to be a little bit of writing, but it's not necessarily hard. The numerator, we're going to do the derivative of this one. What rule would that require us to use? Product rule. Okay, so it is the first thing. This is going to be a lot of product rule because you have r times sine or r times cosine. You have two things multiplied together. So like pretty much all of these are going to be product rule. All right, first times derivative of the second, derivative of sine, cosine. Plus the second thing, sine, times derivative of the first, derivative of cosine, negative sine, over the derivative of x. Now this one would be a chain rule. You would bring the 2 down, it would drop to a 1, and then you have to chain on the derivative of cosine, which would be negative sine. I'm going to put the negative out front, and that's your derivative. I know it looks like a lot, but kind of get used to that. They pretty much look like that because almost all of them involve a product rule. What's that? Oh, the thetas? Yeah, a little Easter egg. Now, I didn't put this on here, but I think I saw a question like this on an AP something or other, and I was like, oh, I'll just throw one like that on our notes. Let's do a second derivative at theta equals 2. That's what, or actually, let me not put a question mark. We'll just find it. Because it was some fancy button pushing in the calculator, and I was like, oh, let's practice that. Okay, so let's just practice doing the stuff in the calculator. So to do the second derivative, you're going to do the derivative of this mess. So it's math 8. This is good because we did review this just now. Do math 8. I know it says theta. If you put it in polar mode, it'll come up as a theta, but it really doesn't matter. Just go ahead and do x. It's just the variable. Alpha y equals will give you that fraction bar. And what you're going to need to do is type this whole thing. So I'm going to stop talking and just go ahead and let you do that, okay? I will just say be careful because every time you hit sine or cosine, it'll start a parenthesis. So you have to make sure you close it. And once you get all that in there, at the end, it's such that x equals, what number did I give you? 2. Do such that x equals 2, hit enter, you should get 3.491. So this is the moment of truth. Okay. All right, so we got 3.491, but you have to divide that by this at 2 again. So you're going to divide it by -2, cosine of 2, sine of 2. So you can either store it, or what I would do is, do you all just have that sitting in your calculator? Just hit divided by, but you're going to need to put a parenthesis around the whole thing so that it'll divide by all of it. So divided by parenthesis, -2, cosine of 2, sine of 2, close parenthesis. And that will be your final answer. But you had better believe that if it was a multiple choice question, 3.491 would be one of the wrong choices. So I just wanted to make sure we talked about it, is all. All right, let's try another one. Find the derivative of r equals tangent of theta. Well, first we have to find y and x before we can do dy dx. So what would y equal? Perfect. It's just whatever's here times sine of theta. And then x would be tangent of theta, cosine of theta. So again, they're both going to be product rules, and your answer is going to look like very large, but then you'll just walk away and leave it alone. Okay. Derivative of y. First would be tangent. Derivative of sine is cosine. Plus sine times derivative of tangent. What would that be? Secant squared. Good. Over, and then in the denominator, we're going to do a product rule for this one. So tangent times negative sine plus cosine times secant squared. It's very repetitive, which actually I kind of like. That's one of the things I like about math, is that it's like just repeats it. It's like, oh, if I understand this, I can just do it again, and then I'm still good. Like the rule, you memorize the rule and then you just can apply it to whatever. All right, number 3, find the coordinates of the horizontal and vertical tangent lines of r equals sine theta, 0 to pi. Write the answer in both forms. So we're going to do polar form and rectangular form. All right, let's do horizontal first. That would be dy d theta equals 0. Now first we have to get y. So what is y going to be? Good. Why is it sine squared? Good. So sine squared. And if you just wanted to write sine twice, you could do that as well. I think it's easier to write sine squared. All right, so let's do the derivative of that. So it's going to be a chain rule. You would bring the 2 down. Gosh, I can't write today. Bring the 2 down. It's going to drop to a 1. And then you chain on the derivative of sine, which is cosine. We're going to set that equal to 0. So you're going to set each of these equal to 0. Do you remember back in algebra 2 when you used to factor things and you would have like x plus 2 and x minus 5, and then you would set that one equal to 0 and that one equal to 0? It's literally the exact same thing except with tricks. So you're going to set sine of theta equal to 0 and cosine of theta equal to 0. Yeah, 0 divided by 2 would just still be 0, so you can kind of ignore that. So now you need to find places on your unit circle where sine is 0. Sine's the y value. So where is that going to happen? Even before pi, 0, and sometimes I'll put pi after that, like no pi, and 1 pi. And here's the thing, you don't have to write 1 pi because here's what's going to happen. When we go to plug in 0, sine of 0 is 0, and that puts you at the pole, which is the origin, 0, 0. So like the pole is any angle of rotation and then 0. Do you get what I'm saying? Like it's still going to be 0. So you can write 1 pi if you want, but it's not going to matter. All right, and then we're going to set cosine equal to 0. That's your x value. So where would that be 0? Good, pi over 2. And 3 pi over 2, but that would be outside of the interval. Now it said to write these in both forms. So I'm going to label this horizontal tangent lines at, and then we'll put the answers. So let's do polar first. This is your polar equation. It's r comma theta, r comma theta. So here's our 0. If you plug in 0 pi, you're going to get 0. So 0 comma 0 pi. And now if you plug in pi over 2, what's sine of pi over 2? One, good. So 1 comma pi over 2. Those are the answers in polar. And we're also going to do them in rectangular. This first one's easy because that's just the origin. That's 0, 0. To get the other one, we're going to need to plug into x and y. We actually didn't write out x yet. Let's go ahead and do that. What would x equal? Good, sine of theta, cosine theta. It's r times cosine. So we're going to plug this, the first one, into both of those to get an x, y coordinate. Well, sine of anything is 0. That's why this first one's 0, 0. Now let's plug in pi over 2. Let's do x first because it's going to be x, y. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So that would just be 0. And then sine of pi over 2 is 1. 1 squared is 1. And those are the answers in rectangular. Don't worry, once we finish this question, I'm going to make you draw a picture. You know that I'm going to make you draw a picture at the end of everything so that we can visually see it because I like a picture and I want you to understand what it is that we actually did. All right, those are the horizontal tangent lines. Now we're going to do the vertical ones. So what are we going to set equal to 0 this time? Yeah, well, I knew what you meant, but dx d theta. I know that's a mouthful. I'm not going to yank you in the hallway and make you take a verbal exam like in language class, okay? All right, so that would be a product rule. We would have first times derivative of the second plus the second times derivative of the first equal to 0. So what is this first part going to give us? Good, that'll be negative sine squared plus cosine squared equals 0. And I would add this one over so that they can both be positive. You're going to end up with cosine squared equals sine squared. And then square root. Now, when you put a square root, you have to put plus and minus. So we're looking for places where cosine and sine are the same like value, but one could be positive and one could be negative or vice versa, right? So think about you can even pull out that unit circle that I just gave you. We need places from 0 to pi where they're the same, but not necessarily the same sign. There's 2 places that's going to happen. Good, pi over 4, 3 pi over 4. Because at pi over 4, they're both root 2 over 2. And at 3 pi over 4, they're both root 2 over 2, even though the x value is negative. But because of the plus minus, the sign ended up not mattering. Oh, yeah. Okay, so if we kept going, what would the other 2 be? Good. And you could keep on going. Like, no, thank you. I'm done. Just keep counting by 4s. All right, so here's our vertical tangent lines. So we're going to do the polar first. We're going to plug back into our polar equation right here. And remember, it's r comma theta. It's like, I get that it's a little bit backwards because it's like you're used to plugging this in and then getting a result, and then we write it the other way around, but it's r comma theta. So if you plug in pi over 4, you would get square root of 2 over 2. So it's square root of 2 over 2 comma pi over 4. And if you plug in 3 pi over 4, sine of 3 pi over 4, that's the y value, so that would still be positive. So those are the answers in polar. And then we're going to write the answers in rectangular. So you would plug in to these right here, x and y, to get an xy coordinate. So first let's do x. If you plug in pi over 4, both sine and cosine would be root 2 over 2. You end up with this. What is that going to give us? 2/4, which would be a half. Good. All right, so x is a half. And then if you plug pi over 4 into this one, same thing is going to happen. You're going to get a half. So a half comma a half. And now we're going to plug in 3 pi over 4. So when you plug into x, the same thing is going to happen, except cosine is going to be negative. So it'll be negative a half, comma, positive a half. Those are your vertical tangent lines in polar and rectangular. Let's draw a picture. We already have all the points we need. 0, 0. I'm just grabbing them from right here. You've got 0, 0, 0, 1, a half, comma, a half. So like right about there. And negative a half, comma, a half. Isn't that cute? Cute. Cute, guys. All right, so your horizontal tangent lines are right here. And then your vertical tangent lines are right here. All right, find the coordinates of the vertical tangent lines. So for vertical, what are we going to set equal to 0? Dx, d theta. All right, so first we need to find x before we can do dx, d theta. So what is x going to be? That times cosine theta. That's honestly how I think of it too. I'm like, that stuff times cosine theta. Can we distribute the two? Because that way when we do the product rule, it'll like at least all be in there. Let me go back and distribute the two. That'll be 2 minus 2 cosine theta. So then I can treat this like the first thing and this like the second thing. All right, dx, d theta. So product rule, the first thing times derivative of the second plus the second times derivative of the first. 2 is a constant, so that's going to go away. Just going to cover it up. Derivative of cosine is negative sine, so the negatives are going to cancel. And so it would just be 2 sine of theta equals 0. Now this is going to be fun with algebra. We're going to have to distribute and factor and stuff here. We're going to distribute this negative sine of theta into these parentheses. You're going to be okay, right? That'll give us negative 2 sine of theta plus, what is that? 2 sine of theta cosine theta? Plus, then this part is also 2 sine of theta cosine theta. I know that looks like a mess, but you actually have some like terms. Do you see how these are like terms because they're the same thing? Add them together, you'll get what? 4 of that. So that wasn't hard, that was just a little bit of writing. Now we're going to factor. What do these have in common that we could factor out? Sine of theta And I would actually take a -2 just to get rid of that negative out front. That's a personal preference thing, but we'll take -2 sine theta. That will leave you with 1 minus 2 cosine theta. And so we're going to set each of those equal to 0. Again, it's just like in algebra when you would factor something and then set each of the factors equal to 0. So this one is just going to be sine of theta equals 0, which will just give you 0. Or actually, how far are we going to go? Oh, okay, so 0 pi and 1 whole pi. This one, when you set that equal to 0, you would subtract 1, so it'd be -1. But then you would divide by a -2, so the negatives would cancel. And you would get a positive 1/2. So we need to find a place on the unit circle, which you can pull out that unit circle I just gave you. You want to find where cosine is 1/2. Cosine is the x value. I'm sorry, say. Oh. That was silly. I'm sorry. My hand was acting like independently of my brain there. Good. Pi over 3 is one of them, but there's one more. 5 pi over 3. Now it says write the answer in polar form. So we don't need to get x and y, which is kind of nice. We're just going to plug those back in right here. And after this, we're going to draw a picture, guys. Okay. So when you plug in 0, cosine of 0, 1 minus 1 is 0. So 0, 0 pi. Now let's do pi. Cosine of pi is -1. So that's 1 minus -1. That would be 2 times 2, 4. So 4, pi. Pi over 3. Cosine of pi over 3 is 1/2. 1 minus 1/2. That'd just be 1/2 times 2 is 1. So 1 pi over 3. And then you're going to get the same thing for 5 pi over 3. Cosine of 5 pi over 3 is 1/2. 1 minus 1/2 is 1/2. And then 1/2 times 2 is 1. All right, let's draw a picture. Actually, we're going to need to make a table of values first. You're going to be okay. All right, so when we plug in 0, we got 0. We already did that one. It's right here. And when we plugged in pi, we got 4. We already did that one. It's right there. So you can go ahead and do those. And actually 2 pi is going to put you back where you started. So that's going to be 0. So let's just go back and do these ones. Pi over 2. Cosine of pi over 2. 0. 1 minus 0 just be 1 times 2 is 2. And if you plug in 3 pi over 2, the same thing is going to happen. That's at the bottom of the unit circle. Cosine of 3 pi over 2 is 0. 1 minus nothing is 1 times 2 is 2. So let's go ahead and graph those. All right. This is the pole. Pi over 2, 2. So you're going to rotate up to pi over 2. That's up here. And then go 2 units. Pi 4, you're going to rotate over to pi, that's over here, and go 4 units in that direction. Where's this one going to go? Yeah, like down 2, because if you go 3 pi over 2, that's going to rotate you around to here. If you go 2 units in that direction, that's going to put you right there. And then we're back to 0. Watch me draw this. Here's how this happens. You start here at 0. You're going to go up to 2, come around to here, and then back again. So it looks like a heart, which is good. We just had Valentine's Day. We have to dismiss one of our answers, and that's why it's really important to always look at the picture. Which one of these is not going to be a vertical tangent line at that point? Do you see how it's a sharp edge there? Not that one because of sharp edge. You're going to have vertical tangent lines at all these other ones. You've got a vertical tangent here and here and here, but not at the pole. No, like as long as you just had these answers, but I would see this more as like a multiple choice question where like one choice would have all of these and one choice would only have those, and it would be there just to trick you. That's how I could foresee them doing that. All right, and then this last little theorem here, I'm just bringing it up because it's true. If you have some polar equation and it goes through the pole, so 0, 0 at some value, and that derivative isn't 0, then you're going to have a tangent line at that point. I wasn't going to make us do a whole new problem yesterday, whatever, last class. Look at example 7 from yesterday. It was this, r equals 2 cosine 3 theta. I'll redraw it for you. You could even just pull out your notes from then. It was that thing that had the 3 leaves on it. It like did this. It's in your notes from last time. You could find it. Gosh, my art skills aren't real great. Let's see. Which is unfortunate because I kind of need to, oh, there, that's pretty good. It needs to be at least okay for you to be able to see what's going on. So we had tangent, or we went through the pole, we found it last time, you can go back and look at it, at these 3 values, pi over 6, pi over 2, and 5 pi over 6. And what this theorem is saying is that you're going to have tangent lines at those values. So here's pi over 6, here's pi over 2, and here's 5 pi over 6. So it's saying if you go through the origin or the pole, then you're going to have a tangent line there. Does that make sense? Because it's a, like you have all those petals, so you're going to have tangent lines. Do you remember on the back of your notes last time how I gave you that thing and it was pictures of all those like rose grass? You'd have tangent lines at every single one of those where it goes through the origin is what that's saying.